Another term that we are going to come across a lot in this lesson is the term heat engines. So what is a heat engine? Heat engine is a device that can receive heat from a high temperature reservoir and produce work from that. While doing so, it will reject some heat into low temperature reservoir. Here I have internal mechanism of a heat engine. We have a boiler, we have a turbine, we have a condenser and a pump. This can be a steam power plant. For an example, I can take liquid water that is coming out of the condenser, pump it into the boiler, and in the boiler I have flames, which is the energy source, which I absorb heat from that, and I boil the water that is coming into the boiler into steam, and I send that steam into a turbine. The turbine produces work output, and the steam comes back into the condenser. It gets cold, becomes liquid water, and goes to the pump again. So the cycle continues. So this is a cyclic device. So this cyclic device takes heat from high temperature reservoir and rejects heat to the low temperature reservoir. Also observe that it is consuming work in the pump, and it is producing work output in the turbine. So the net amount of work that is generated in this cyclic device is W net, which is equal to W out minus W in. Let's discuss about calculating the thermal efficiency of a heat engine. Thermal efficiency is defined as useful energy output divided by energy input. So what is the net work output of a heat engine? It is W net out. And the heat input is going to be Q in, which is QH in this case. So W net out, using energy balance, we can write is equal to Q in minus Q out. If I substitute this into my equation, I can rewrite that efficiency is equal to 1 minus Q out divided by Q in. If we are using the notation that we used on our heat engine, we can write it like this. Efficiency is equal to 1 minus QL divided by QH. Now let's try to do a very simple problem about calculating the efficiency of the heat engine. I have given you all the information that you need, equations and figures here. And assume that you have this kind of a setup. There is a furnace, and you have a heat input to your cyclic device 80 megawatt, and heat is rejected to a river 50 megawatts of heat. So you are asked to calculate what is the net power production, and then you are asked to calculate the efficiency. Try to solve this problem and come back for the answer. So net power production we can find using energy balance equation. So if you want to write the energy balance equation, QH is our heat input, and QL and W net out are going to be our output. So QH is equal to QL plus W net. So we can write W net is equal to QH minus QL. That is going to be 30 megawatts. The efficiency is defined as W net out divided by QH for a heat engine. That is going to be 30 megawatt divided by 80 megawatt. That is equal to 37.5% efficiency. A refrigerator is a device that takes heat from cold space and rejects it into the warm space. While doing that, it normally consumes a net amount of work. Heat pump is a very similar thing to refrigerator. The only difference between a refrigerator and a heat pump is the objective, what we are using it for. If you think about your refrigerator, it is there to remove heat from cold space. On the other hand, if you are thinking about a heat pump that you use to heat your room, the objective is heating your room.